Hi, and welcome back to my OpenTK 2D game engine / framework series. This is part 8. In this episode, we're going to implement handling multiple textures. This is by no means the only way to do it or the best way to do it. In fact, if anybody has any recommendations, please leave them in the comment below or leave a way for me to contact you. I would love to see somebody else's implementation of this, not only just for this series, but also for a game engine that I've been working on the side. So if you remember from the last episode, we were able to get a texture on the screen and we were able to apply a color to it using our vertices here. So for now, let's go ahead and create a new implementation. For those who have been following this series, this should just be muscle memory for you. Otherwise, if you have not, just follow these instructions. In your texture with colors from the last episode, Control-A, Control-C. Go into Implementations, click Create, New Item, and select, on this one we'll call it Multiple Textures. Control-A, delete, Control-V, paste. If you're lazy like me, right-click, rename, Control-C, scroll up to the top, or just type out multiple textures, go into your game program, and change this to multiple textures. Control-F5, let's see, make sure everything runs. And it does. So now let's make a copy of our texture with color.glsl. Just go in here, Control-C, Control-V, and we'll rename this to texture with color and texture slot. You do not need to set it to copy always. It will do it by default if you copy this. Otherwise, if you went through and manually create the file, you will have to make sure you go into here and say copy always. So let's update our multiple textures class to use this new shader. Just shouldn't be any issues, but stranger things have happened. And we are in business. Okay, so I think for sure we're gonna need a couple things, right? We're gonna have to update our shader class to get what's called a uniform location, and then we also need to update our shader to allow us to pass in which texture unit that it's going to use. So today, when you call the use method on texture, it just assumes that you are using texture slot 0. That obviously is not the way you'd want to do it unless your game only has one texture, in which case this works great. Later on down the road, we will probably create a method here that we can pass in the texture unit as a parameter and call use on it. That's yet to be determined. So let's start with the shaders. So the shader, let's go into our shader in core here, in rendering, I believe. Yep. And we need to be able to get what are called the uniform locations. So uniforms allow us to set data, say for instance in our update method. I don't know if it's a bad practice to do it in your render method. It could be. I would have to confirm that. But today we're just loading the shaders and we're not doing anything with it. So this is fairly similar to how you would find it on the way that the Learn OpenTK site does it. We'll leave a link to in the description to that as well. But what they do is they keep a dictionary of uniforms, and that seems to make the most sense. So up here we will create a private read-only, read only. Thank you. Dictionary, and we'll call it the string will be our key, and int will be our value. And we'll call it uniforms. We'll say new dictionary string int. And then when we are compiling the shader, we can go ahead and just set these values. And it's actually pretty simple to do that. After you can do this even after you have deleted your shader and everything else. There's a method called gl.getProgram, and you can pass in a parameter name and then get the value for it. So it's gl.getProgram, program ID, and then get program parameter name dot active uniforms. And then we need an out variable called total uniforms. Not total uniforms, total uniforms. I swear it just changed that to automatically. Okay, so now we need to loop through all these. So we'll do for int I equals 0, I that is less than total uniforms I++, And we'll just go ahead and get the key. So string key equals gl.get active uniform. I'll call it program ID. The uniform index will be I, so we're just looping through these, so it'd be the first one that we're working with here. These don't matter. These are some out variables. We can just discard them. We don't need them. Program ID. There we go. So now we need to get the location of it, and we can keep track of that by doing int location equals gl.get uniform location. Makes sense. And program ID, and then the key, and then we will simply add it to our dictionary. So uniforms.add key and location. So now that should automatically load these into memory. We can test that by opening up this, and we'll create a new uniform that we're going to add, and actually we'll just make use of this one. We're just going to change it up a little bit. So it's still going to be a uniform sampler 2D, but we're going to call it u_texture array. So it's an array of sampler 2Ds. And then inside our code here, we're going to accept an index, and then we're going to index into that. So just to make sure that this compiles for now, let's just do this. You don't have to copy this. You can wait before you do this part, just in case there are issues. I just want to make sure we can compile this and take a look at those uniforms as they come in. Alright, so let's go ahead and do that. We'll set a breakpoint in our compile shader method here, and let's take a look at what it does. Actually, I don't have any other breakpoints. Okay, let's fire this up. Alright, so we're going to call get. It's going to give us our total uniforms. Should be the value 1, and it did not. So let's see why. Was there a compilation error here? Okay, so that error actually makes sense. It's getting active uniforms, and currently this is not active. We're not using it. So that's kind of neat. I just learned that here about OpenGL here, is if you are not actively using this texture, it's not going to bring it into the active uniforms. So for the time being, we can just do this to make it active. So we'll do int index equals 1, and then we're going to set our output color will be equal to texture, and then we'll do u_texture, and we'll just pass an index, or we could have just passed in 1, 2, I guess, but we're going to actually have to set this value eventually, and we'll just take that times the color. Oops, wrong, I forgot to remove that. Hang on. Also can't forget the text chord so it knows where it needs to go. There we go, and we get the same result. So let's go back into here, and we'll go back into debugging this shader here, and let's make sure we get this uniform to come back. So now we press F5, and we get 1 uniform back. So let's take a look at what these values look like. So the key for this becomes texture 0. This is the part that has somewhat thrown me for a loop, is this becomes the name of it. To me, this doesn't seem like that should be the case, and it's possible I'm just doing something wrong. So again, in the comments, if you know anything about this, please let me know. So now it's location. We'll call GL uniform location on the program ID, passing the U texture, and its location is 0, and it's just going to add that to our uniforms. All right, now we're set. We can actually set these values. Let's start by creating a method that will return us the uniform locations, because it's currently private. We don't want to really be able to set this outside of this class. So let's do that. Pretty simple. Let's do a public int get uniform location. We'll pass in string uniform name, and it will just simply be a return on this, a uniforms, and then uniform name. So that'll give us our uniform location. And then from there, we need to be able to set these values. So we need to give it some data so it knows. And these values are just going to be 0 and 1. That's all there really is to it. So we can do that after we have done our index buffer, right before texture loading. I think that should be fine. We'll do var texture sampler uniform location will be equal to shader.get uniform location, and remember that was u_texture 0. It has nothing to do with texture slot 0. That just seems to be the name that OpenGL is assigning to it with this here. Again, I'm not sure why, but we know what it means and we're able to still leverage it. So now we need to create these samplers, and those are just going to be the values of 0 and 1. So we'll just create an int array, and we'll call it samplers equals new int, and we'll make it size 2, and we'll simply give it the values of 0 and 1. And then what we can do is just call gl.uniform1 texture sampler uniform location. There is 2 of them, and the samplers. Alright, and then that should be enough to be able to set these values. So we're going to need another texture to load. Let's start by that. Head on down to the description and you will find a link to an image that was taken from the Learn OpenGL website. I will also leave a link in the description to their site. Highly recommend their tutorials. That is where I have learned the majority of what I know. Even though it is in C++, it's very easy to translate into OpenTK. So go ahead and download that image and save it into your textures folder here. Also, be sure to come into here and set it to copy always. If you don't do that, you will get an error, and we'll hit save all so it saves the CS proj. So now we also need to be able to handle texture slots here. So today we don't really have a clean way. We're just assuming everything is in texture slot 0, right? So when we call load texture, we need some way for it to be able to store the texture slot and also be able to get some information about that texture, because eventually here what we're going to start doing is only start drawing just sections of a texture, right? Because let's say we had a sprite sheet, we might want to only draw something at, maybe let's pretend this is a sprite sheet, maybe we only want to draw here to here, or we only want to draw here to here. Well, we need a little bit more information about these textures in order to make that happen. So let's go into our load texture method and into our texture factory.load. And then from here, we can have a texture cursor, and this will just keep track of what active textures have we currently been working with, and we can use this to build up the name of the enum and work with it. So we will call it let's do it private, so private static int texture cursor, and we'll set it to 0. And then this can all stay the same. Now we need to try to get that enum value here based on which texture cursor we're currently at. And we can do that pretty easily just with some typical .NET out-of-the-box work here. So we'll do enum.tryParse, and it's the type of texture unit. And then we can pass in texture, and then simply texture cursor, so it should be texture 0. It will pick up on that and should give us that value. So we'll do outvar result, and that should be our variable or our value. And let's do a good check here to make sure it's not null, because if it's null, there's a chance that we've probably exceeded the amount of texture slots. There shouldn't really be any other reason, but we can probably, for now, we can just safely assume that's the issue. So we'll do let's go ahead and just throw an exception at this point, because the application cannot continue. So we'll do something like exceeded, that's how you spell it? Just doesn't look right, whatever, okay. Maximum texture slots OpenGL can natively support, and then we'll give out the count, because maybe that could be useful information. Could mean that we just have something with the texture cursor not being set correctly. So if that count says something like 500 or something really just crazy and out there, obviously it wouldn't. You don't have that many texture slots in any machine, but just for example, you might lead you some hints that it is using up all the textures, but you have something else going on. All right, so now we can just create a variable for the texture unit, and it will just call it texture unit, and we'll go ahead and cast this to the result. So we'll do texture unit and pass in a result. So now instead of hard coding this to texture 0, we're going to set it to the texture unit. Okay, texture 2D, that all remains the same. I don't see any more references to texture slot 0, so that looks good. Okay, I think that will work. We're going to hang out for now on setting the size of the image. We'll come back to that. But, oh yes, also we have to make sure we're incrementing that cursor. So cursor plus text cursor plus plus. So let's make sure this logic is working. Oh boy, I can't believe I didn't remove those unusing using statements. So let's go ahead and make sure that our texture cursor logic is working correctly. Let's set a breakpoint at loading texture. We'll go into here, or not the shader, but we'll go into our multiple textures here, and let's just go ahead and load these. Like, we technically don't really need to call use here because we're going to be setting it based on what's being passed in here in these vertices. But for now, let's just go ahead and load both of these. We won't assign them to any particular variable. So this one would be awesome face.png and wall.jpg. So yep, this one's a PNG, this one's a JPEG. Make sure you get that one because that could cause some issues. On hindsight, I probably should have kept them all JPEGs, but it doesn't matter. So let's go ahead and debug this and make sure it is working the way we are expecting. So texture cursor is currently 0. It's going to try to parse that value out. It is not null. It's going to set the current texture unit to texture slot 0. Next one comes in. Our texture slot was incremented. Let's make sure we're getting our texture. Texture 1, perfect. Texture unit is 1, and the active texture is texture unit 1. And it probably should just load the wall. Perfect. You know, I've been trying to keep these episodes short, but let's just go ahead and expand our existing texture 2D class. So go ahead, let's go into our texture 2D, and let's create some more constructors so we have some ways to work with this. But also we need to capture some additional values. So let's do a public int width, get set. We'll do a public int height, get set. And let's go ahead and capture the texture unit, why not? We'll do public texture unit and texture slot, and then we get set. But we also just wanted to support legacy and these older constructors, so we can still go back and use some of our old stuff. We'll just have it default to texture unit 0, so it assumes that it's, if you do not supply this during the constructor or explicitly set it, it will just fall back on the old way that we're handling textures. And there might be some instances where we don't care about the texture slot, but maybe we just want to set the height and width, and that's all pretty easy to do. So let's go ahead and create a constructor. So public texture 2D, texture 2D. It'll be int handle, int width, int height, and we can call this to pass in and use this constructor to set the handle, so we're not setting this code twice. We'll set the width equal to width, and the height equal to height. And let's make another constructor that's going to also accept the texture slot. So we can do public texture 2D, int handle, int width, int height, texture unit, texture unit, and we can just call the previous constructor so we don't have to duplicate anything. Handle, width, height, and then we will set the texture slot, or texture slot. Yeah, let's just, our naming is not consistent. Let's change this to texture slot, even though it is texture unit. It's used interchangeably. So now we want to make sure we're setting this value when we are creating these textures. So let's go ahead and do image.width, image.height, and then we'll pass in the texture unit. It was texture slot, but that's fine. Texture unit. There we go. Let's confirm we've made no mistakes. Everything should look the exact same. Perfect. Let's go back into our shader class, and we're going to pass in the index. So let's do that. Let's create a new layout location. We'll set that to 3. It'll be an in float a index, and we're going to need to pass this into the fragment shader, so we also need to create an out variable. So we'll do out float text index, and then let's make sure we're setting the text index. So text index equals a index, and then down here we'll also need to pass it in, so we'll have in float text index. Naming matches up here, looks good. And then we need to convert that to an integer, so we'll keep this int index equals this, but instead we're just going to use the int function and then pass in the text index. This way we can keep everything floats, and we'll just have the shader take care of the rest. And then that should be all we need to do. All that's left in the shader here, yep, we're setting it to size 2. So now we can go back into our multiple textures class here, and let's get rid of texture here. We don't need it. We're just going to load these up into memory. It's this resource manager and the texture factory. They're going to take care of handling the texture slots for us. We don't even have to think about it. We just need to know which texture slot we're working with. So let's go ahead and add some floats. You can just hold down Alt and then drag your mouse down after this, and just let's start with 0.0f, and then make sure you add your comma at the end of these, and then a comma after this one here, and then you can take out the comma here. So now we'll be passing in another float in with our vertices, so we also need to update our buffer layout because that has obviously changed. And with the abstraction we built here, that should be very simple. We will do buffer or layout dot add float, and then we will push one float. So it's currently loading this. The wall is going to texture slot 0, and awesome face is going to texture slot 1. We are currently just testing with texture slot 0, so nothing should look any different. Then let's try changing all of these to 1s. One mistake, we need to call shader.use down here after we have set the buffer layout. And then now we should see, shader.use. So now we should see these awesome face, and it's tinted pink. So let's go ahead and change. So let's take a look. We should probably document these. So this is positions, texture, chords, color, texture slot. So let's change these to just all to white. So we have positions, texture slot, 1.1, change all these to 1, and that should make this appear white. Yep, well, it's no color now, so it's showing its true color. We'll try changing this back to texture slot 0. And it works the same. Alright, so now we do have a way of handling multiple textures. I think that we'll call the episode right here. I'm not going to make any more promises on what the next episode is going to be about, because it seems like I always say what it's going to be and then it never ends up being that, because I find ways where something seems like it'd be way more important than the other. So the next episode is to be determined. I am doing my best to try to stay on track with 1 episode per week. So if you like what you see, please like and subscribe, and we will see you in the next episode. Thank you.